Welcome everyone to the final event of EnerMaps. I would suggest that we go already to the next slide exactly. So I'll just quickly introduce myself. My name is Jakob. I'm the coordinator of EnerMaps Horizon 2020 project, and I'm also the director of the Crem. I'm happy today to guide you through the program, which is the following. When we look into the detail, on the next slide, yes, thank you. We'll have a little introduction to the project from my side. We'll talk and learn a little bit more about fair and open data for energy transition before we jump right into the concrete project, the outcomes of EnerMaps. How did we work on the data selection? What is a data management tool, and how might you be able to use EnerMaps for your use cases, the integration of additional data sets, what is the IT behind the scene, how is it working? And then you have the chance to enter the Q&A, where we can discuss points that came up during the different presentations. After each presentation, you might have the time to just quickly have a question for understanding. So if there's a word or something on the slide that you did not get, feel free to post it in the chat and we'll take it up and ask the question right away. More complex questions will be treated afterwards in the Q&A. We'll get then a little reminder of our training program that's coming up on Friday, so tomorrow, before we all have a well-deserved little coffee break, and then go into the networking sessions that allow us to dive a little deeper in EnerMaps for researchers and developers, or EnerMaps for practitioners and decision makers. We'll conclude, we'll give some ideas of how EnerMaps will evolve in the future, before we can again split out into networking and have a little informal chat on things that came up, exchange and see what new ideas can be created. I'd like to remind you that this event is recorded, so please be aware of that. We'll publish the stream afterwards. So that is important for you to know. In case there's a problem with that, please reach out to us as quickly as possible within the next couple of days in case there's something that should not be shared. With that being said, I'll go right into the plenary session that we'll have now. So you have the introduction from my part. We'll have an input from OpenAire on the open data. And then we'll discuss in the outcomes of EnerMaps with the methodology presented by Eurac, visualization tool presented by the Crem, and the analysis tool, as well as the future uses by Idiap. Next slide. During the breakout sessions, just to give you a little bit more detail on that already, you'll have to decide, and we'll show you how to do this on this platform, on whether you want to join us on the first session, which will be really on the tool for research purposes. How can you create analysis tools? They will be introduced and demonstrated. Whereas in the second session, we'll have a different point of view. Well, we will look at EnerMaps as a decision support tool in policymaking. We'll have a feedback from a guest. We'll discuss a little bit the story maps that you can create with that, so that they can help in reasoning and in policy making, in decision making. And afterwards, in both cases, you'll have the possibility to exchange directly with the people that were presenting. Next slide. Finally, for the outlook, we'll have an invited speaker with David Wannier, professor at HSSO Valais and coordinator of the OpenGIS4Net project. He will give you a little bit more detail on this before we can go then in the final networking session just before noon. So next slide. Just a reminder on training. The training event will be tomorrow. You can still join us. Normally the link should be available now in the chat. Feel free to register, and you'll have a hybrid training on the tool and how can that be used, the different CMs, calculation modules, how we like to call them, those analysis tools, so that you're able to write your own data story. Next slide, please. EnerMaps. So what is the idea behind this? What problems are we trying to solve? That's the general introduction from my side on the next slide. So you all, I think, have seen that if you go to, if you look for data, you'll find data. However, the formatting, as you can see already in the title of my slides, we're talking about the 4 letters that are all the same. However, you can write them in different ways, and that makes a huge difference in case you try to analyze this data and get conclusion out of it. Here you have different ways of spelling the same words, and that might already screw up your analysis. And yeah, that's a constant constant problem that we have when we look for data. We'll find something. It is often unstructured. We'll go on the next slide. You will sometimes not even find it. It might be confidential. It might be fragmented. It might be incomplete or disposable, in terms of that you'll have to delete the data after the study, so that in the next one you cannot really use it again. And this is why we created really with EnerMaps an energy library, where we try to collect, if I use this analogy, the best books. So that means that we have a quality check. However, we remain inclusive, which means that we link toward other books that exist, that, however, due to the time that we have available, we were not able to check in all detail or not include because a similar data set already existed. We provide you with different indices so that you don't get lost in this library. So you can search through the existing work, either by geographically, by author, by year, by topic. There are different indices that you can use in the different databases to search. And finally, and I think that is also a very important part, we have a visual toolkit that allows you to see the data and have a first analysis tool on it to get conclusions out of it. So that you can do more than only walk in a library. You can already work there and get something out of it. The best, I think, to wrap this up, it's online, it's all free, and it will go on for a while. So that's I think the good part. And now we'll go into the more detail on the next slide, where we'll just, remind you of what EnerMaps does. So basically, we sort out the data confusion for you. We'll provide you over 40 data sets that you can use and work with, that are quality checked, and give you really a starting point in your analysis. And you can, of course, afterwards combine it with your own. Next slide. With that, I'd like to remind you of the consortium that has been working behind the scenes and that you will meet today in the different sessions that we have. So we had the Crem that is doing the overall project coordination, Eurac on the first work package data sets, Idiap on the database part, Theovin joined us for data enrichment, OpenAire with all the knowledge on open science and open data, linking it to existing initiatives, and eThink doing the training and capacity building, while Revolve is not only managing this event, but also doing the communication and dissemination of the event. Next slide. So let's get started. Really, what is fair data? As a reminder, fair data means you have findable, accessible, interoperable, and reusable data. Next slide. And this is what EnerMaps is about. We try to give you a visual access into the existing data. We link that to existing other databases so that the community can be there and can reuse and not only the data, but also the training materials. We have a digital tool on the energy transition that hopefully can accelerate and help you all to work with that. With that, next slide. I'd like to conclude with the objectives. So we centralize the data sets within the tool that we'll show today. We'll try to improve the accessibility of scientific data sets that exist. We try to ensure the quality and share how we do that, and increase finally the energy acknowledgement through the training activities that you can still join. Next slide. With that being said, I have spent, I think, almost the 10 minutes that I have already. And I'd like to hand over to Alessia Bardi, who's joining me now on scene from OpenAire, and that will share the introduction on open science and fair data with us. Please, Alessia, go ahead.
Thank you, Jakob, for your introduction. So, as you can see in the title of this slide, we will address the topic of fairness and openness and how they are indeed the foundation of the work we performed in EnerMaps, but also for the future use of the tools that we developed during the project. Next slide, please. So when we talk about open science, it is a very wide concept. So we can define it as the practice of science in such a way that we can collaborate and contribute to research, where we can reuse data, but not only data, also the research processes that created that data. So everything that comes from a research activity should be shared with licenses that allow their free redistribution, reuse, so that everything can be combined together again. Uh, but but open science is not applied only within the academia, but also to the wider civil society. So you can see it as a tool to foster innovation, uh, improve the linking and the collaboration between the academia and industries, companies, and citizens as well. Next slide, please. And there are many practices. So it's not that you do open science like this, because there are many practices that we have to put in place. And they range from the open access publishing of publication to fair data, open data, the fact that you can share every types of research products that you produce and you make them available via open repositories. And these are only some of the practices that researchers can follow in order to embrace open science. And why this is done? This is to reach the goals, the objective of open science that you can see on the right of this slide. So to have reproducible research, a transparent evaluation, and an omnicomprehensive scientific reward that does not is not confined to the reward for writing publications, and of course also responsible research. I already talked about the maximization of the innovation potential and the openness towards towards the society. Next slide, please. So, to make open science a reality, there are different activities ongoing from the point of view of the policies and from the point of view of the technical infrastructures. So, from the point of view of the policies, I would like to mention those from the UNESCO, for example, that consider open science as an accelerator for achieving the Sustainable Development Goals and to make research more inclusive. Then we have the DORA. The DORA policies. DORA is an initiative for research assessment. So it was endorsed by several research organizations, also the European Research Council. And the idea is to eliminate the journal impact factors and give value to all the research outputs. And maybe the most known policies are those of the European Commission, especially the open access mandate on publications and data, and um, and recently also the opening of the Open Research Europe publishing platform in order to support the implementation of the open access mandates. From the infrastructure point of view, instead, there are a lot of activities ongoing in the context of the European Open Science Cloud, whose goal is to provide a multidisciplinary environment where researchers in Europe can find data services that they can use to conduct their research. And and then we have OpenAire. So OpenAire is the open access infrastructure for research in Europe, and it's been a lot of years that is working to provide support for the implementation of open science practices, both from the technical and from the support point of view, thanks to a network of national open access desks. Next slide, please. So how this fits with EnerMaps? So on the one hand, we have improved the fairness in the field of energy research. Um, so we provide a tool for the discovery and access to energy data that is usually scattered across different repositories. And we did this thanks to the EnerMaps gateway that will be presented during this later in this event. We provide detailed machine-readable metadata and documentation for humans for the high-quality open energy datasets that Jakob was mentioning before. And we facilitate the processing of this data with the visualization tool and the calculation model that it integrates. But we also link the energy field with the open science infrastructure. So the EnerMaps gateway is implemented on top of the OpenAire research graph using one of the services of OpenAire, which is called OpenAire Connect, thanks to which we could create this thematic portal with all energy-related research outputs. And the gateway is integrated with other services, just to mention some that are very important. ORCID, which is for assigning persistent identifiers to researchers, and EUDAT B2 Note, which allows you to create personal note or shared note attached to research products. And finally, the EnerMaps data management tool will be offered, I mean, is already available, but will also be offered as a free open service in the EOSC marketplace, so the European Open Science Cloud catalog, so that it can reach a wider audience and all over Europe. So I think this concludes my presentation.
Thank you, Alessia. I don't see any questions yet. So either we have been very good in explaining what we do, or you're still shy out there. So please reach out and ask in case you have a question. With that being said, again, I check quickly. No, I don't see any. So I would go then to the next presentation. Alessia still remains with us during the day, so you can keep your question and ask it later. I'll ask Eric Wilczynski now to join us up on the scene. Eric is a researcher at Eurac in Italy, and will now talk about the methodological approach on data selection, validation, and the metadata. Eric, the floor is yours.
All right, thank you, Jakob. Hi, everyone. My name is Eric Wilczynski. I'm with Eurac Research. And yeah, for my presentation, I'll be going over the EnerMaps project's methodological approach, including the data selection, validation, and metadata, which was largely an effort from work package 1 of the project. Next slide, please. Here's a brief overview of the topics I'll be covering in this presentation. After an introduction, I'll discuss the inventory creation, then the quality check process, and finally go over some of the ways we gathered feedback into the process. Next slide, please. So the core of EnerMaps is the data itself, which will be the focus of my presentation this morning. As Jakob mentioned, energy data is often difficult to find. It's located in different repositories and fragmented, which can result in project delays and lost time and money. So EnerMaps seeks to address these issues by providing a quality check database of crucial energy data that will communicate and disseminate data effectively and efficiently using practices to make the data more findable, accessible, interoperable, and reusable or fair. As such, data is central to the EnerMaps project, and the EnerMaps data management tool will be a hub for energy data. The focus of this presentation, and also one of the initial efforts of the EnerMaps project, is to identify and select the initial data sets, which will form all the core of the EnerMaps data management tool, and then to validate these data sets. Next slide. So as mentioned, the main goal of this phase of the project was to create the initial inventory of the data sets that will be added to the EnerMaps data management tool. Many of these data sets will then undergo a quality check process to assess the quality and consistency of the data. However, there are some other criteria that acted as a jumping off point for selecting the data sets. So first, renewable energy data was intended to be a large focus of the initial data sets to ensure that the platform is useful for future trends in Europe's energy research. In addition, there was an emphasis on datasets from national and European statistical offices, such as Eurostat and European Environmental Agency, due to the high quality of these datasets. And finally, around 15 of the datasets were required to be from recent publicly financed research and innovation projects. The reason being is that datasets from these projects will especially benefit from EnerMaps since they are not always well known, easy to find, and in some cases, not easily downloadable or available for download online at all. Next slide, please. So we took two primary steps in assessing the data demands of the energy research community. First, we gathered insights on crucial energy data categories by conducting a review of journal papers, conference briefs, and similar articles on the common data sets and data demands for energy research, taking note of the types of data used in these papers and any data demands that stakeholders may have mentioned needing but not having access to. Second, we conducted a stakeholder analysis to identify a sample of experts who were then interviewed to assess their energy data demands. The selection process was designed to ensure a diversity in experts, both in terms of their field and their demographic background. And experts were asked to provide examples of the data they required most and to describe user stories for their energy data demands and issues. Next slide, please. So when selecting the data sets, we considered the following principles. First, we considered the data demands of the energy community that were identified in the previous slide, including specific data sets that were recommended by experts. Second, we had a few project prerequisites. This included an emphasis, as mentioned, on renewable energy data, ensuring that a significant portion of data sets were from publicly funded R&I projects. And finally, ensuring that the data either focused on Europe or that Europe was included in the geographic scope of the data set. Finally, we want to consider a diversity of categories to ensure that a variety of data was selected. Next slide, please. So next, I'll briefly go over the quality check process, or sometimes referred to in the presentation as the QC process. This process was important that it verifies that the data sets are accurate, consistent, complete, and that its creators were transparent with regard to its creation. Next slide, please. So this table shows an overview of that process and the breakdown of how we organized our work. The first step we had to do before starting the quality check process was categorizing the data sets into 3 levels, which determined the extent of the QC process each data set underwent. So level 1 data sets were primarily data sets that were identified by experts and only underwent a cursory portion of the QC process, including a review from experts and a check for metadata. And the level 2 and 3 data sets underwent nearly the entire QC process. The one difference being is that level 3 data sets also underwent an additional step and received a high level comparison with 2 similar data sets. However, the core of the quality check process included the methodology check, where we checked for the presence of documentation associated with the data set that explains how the data was created. The completeness control, where we conducted a quick analysis of the data set to check for blank or null values. The statistical accuracy check, which was also part of the documentation review, and was basically where we checked for any elaboration from the authors on the statistical accuracy of the data set. And finally, the consistency analysis, which was conducted by testing for the correlation of the data set with a similar data set, either a data set that was a similar measure of that data set or 2 different measurements that were logically correlated, for example, like electricity consumption and population density. And finally, all data sets were made available for review from users at the EnerMaps Scala social network, which is listed in the second step. Next slide, please. Yeah, and the last part was gathering feedback throughout this process. So stakeholder feedback was a vital component of this effort and a key contribution to the 3 project tasks listed here. As mentioned, external experts were interviewed in order to assess energy demands and gather user stories right before we even started the process. These user stories were also used when guiding the development of the EnerMaps data management tool and its features. An internal focus group meeting and review session among consortium members on the dataset collection process was conducted to gather feedback on the process, the QC process, and the results. And finally, another group of external experts, different from the first group, were interviewed to review and provide feedback on the dataset selection and quality check process. And the feedback received from all these tasks were used to improve the dataset inventory and the QC processes. Next slide. And yeah, thank you for your attention. I would like to welcome Cédric at Crem as the next speaker in the session. Thank you.
So, thank you, Eric, for that introduction. I see you got first questions, but we'll keep them for the Q&A. And I see that Cédric is already there in the starting blocks. So, Cédric, please talk a little bit about the data management tools that are available thanks to EnerMaps or that are linked to EnerMaps. Cédric Serugendo, the floor is yours.
Hello, everyone. I suppose that now you hear me. Yes, perfect. So I will just introduce myself quickly. My name is Cédric Serugendo. I'm working as a R&D engineer at Crem Research Center located in Martigny. During this presentation, I will give you an overview of the two main tools developed during the EnerMaps project. The first one is the EnerMaps Gateway, which is an energy library integrating an engine, search engine that aim to compete with the Google Scholar in the field of the energy. And the second one is the visualization tool, which is a tool that allows user to map georeference data and try to process it. Just maybe the slide going too quick. If it's possible to, yes, perfect. So I will introduce you to the first tools, which is the gateway. In this gateway, we made the effort together in one place, a lot of data sets related to the energy. As you can see, there is more than 2 millions of data set available. There are more than 400 research data and 300 software and so on. And among of this data set available, there is data set that has been quality checked as presented by my colleague Eric Wilczynski. And it's possible through this platform to go in more detail about the future data sets. And when I say future data set, I mean you have the possibility to have access to the metadata related to this data set. You have also access to a link where the data set is hosted, and you also have the possibility to visualize this data set directly through the visualization tools. And if you want to play with this research engine, this platform is already available online, and you can access it on enermaps.openaire.eu. Next slide, please. As I said, there is two tools developed in the EnerMaps project. The first one was the EnerMaps Gateway, and the second one is the visualization tools. This visualization tools is was thought on the principle of several layers, where each layers enrich the previous one. The first layer is just a map that covered the whole world. Of course, this map comes with the classic navigation tools, which allow user to just go over the map easily. The second layer is the data set, which enrich this the first one layer. In this dataset, we can find all the dataset that has been reviewed by the project partner. This dataset appears in the panel on the right, and you have the possibility to search for the specific dataset you want. You also have the possibility to reduce the number of the dataset you retrieve as a response by selecting a specific category. The communication between visualization tool and the gateway is bidirectional, meaning that you have the possibility to just select a dataset and ask for more information about this dataset. And here you have for each dataset a link to the gateway. Once you have selected the dataset you want to explore on the map, this dataset appear in the layers panel just on the right, just below there. And you have also the possibility to appreciate this dataset according to the panel legend on the left. The last layer is the analysis tools. This analysis tools is a small tool that allow user to perform some analysis on different layers. This analysis tools is available also online on visualization.enermaps.eu. The visualization tool is an open source tools available on GitHub. Next slide, please. As I said, several analysis tools has been developed in the framework of the project EnerMaps. The tools will be presented more in detail by my colleague Pietro Zambelli, but I will just give an overview of each of these analysis tools. The first analysis tool is the district heating assessment. This tool is used to evaluate the potential of district heating based on more economic aspect. The second one is the heating cooling degrees days. This tool is used to estimate the change in heating and cooling degree days due to the climate change. And the third is it's also a tool to estimate the potential of district heating, but this time is more based on heat demand. Next slide, please. The building load on these tools is used to estimate the heating demand in profiles. The refurbish rate estimate the heating and the cooling saving potential in a building based on different scenario. And the heat learn is used to estimate the annual aggregate heating demand of a building. All this tool is documented in the wiki of the project, and you can retrieve this the page dedicated to each dataset directly in the panel of the dataset. That's all. If you have any question, I'm at your disposal.
So we'll change on the fly, and I'm right back. So thank you, Cédric, for the presentation on that. I see that the chat is now starting to be active. You get first replies from our side. So that seems to work. That's great. With that, please keep them coming, those questions, so that we have some also for the Q&A. I'll now hand over the microphone to Giuseppe Peronato, who will talk about the data sets and their integration into EnerMaps. So Giuseppe, please, the floor is yours.
Yeah, thank you, Jakob, for the introduction. Yes, I will briefly introduce the behind the scenes of EnerMaps and also give some perspectives about the future developments. Next slide, please. So one of the main challenges of EnerMaps was indeed data integration from different sources and providers. Next, please. This is to give you an example of some of the providers that we used in EnerMaps that we aggregated data from, ranging from established data portals to Git repositories. Next. So they all come with different data structures, some more structured, some more unstructured. The most problematic ones are, of course, the unstructured ones. Next. But fortunately, a recent trend is the addition of a data package containing metadata, and this was particularly useful for the data integration, helping us to know how to deal with this data. And maybe I would encourage all researchers and data providers to use such a such system. Next. And in our data sources, there are also very different levels of accessibility. Here, indeed, the most problematic ones are those behind maybe an access wall where a login is needed. Next, please. In this case, we could integrate the datasets, but this will not be updated anymore in our site. Next, please. So to summarize the challenges, we have different data providers, often with non-consistent formats, and in some cases with an access wall. And but EnerMaps provides some solutions, some custom data integration pipelines to help fit the different data in a unified database schema. And of course, we offer an open visualization platform and also an API. Next, please. So I go here in more technicalities, and sorry for that. So the integration requires some data transformation, and I will give you some example. So this data transformation to fit the formats to one database schema. So for tabular data, this is the first example. This meant, for example, unpivoting values and adapting country codes to a common format. Next, please. And for raster data, this meant, for example, having a unique projection and also using a single format as files and also with a single band. So, for example, in many cases, there's time as one of the bands of the raster, and we use separate files to have the same structure for every data. Next, please. So the second part of my presentation will present some the development guidelines and best practice that we used in within our project. Next, please. So, for example, one single Git repository, including most of the code best practice, and then Docker services with the principle one task, one service, one subfolder, and everything orchestrated with Docker Compose. So again, for the if it's too technical, but this meant having code that is reusable and also making easier to make the software easily maintainable and deployable in a different context. Next, please. And here it comes to the database design. Here also we were guided by some simple principles, a few data tables or spatial information in the same table. And as we saw before, we stored raster as files, and this meant not having directly in the database, but as external files. And also we had we did quite a big use of binary JSON as a method to overcome some of the limits of a relational database in having a more flexible data structure. Next, please. So here is an overview of the database. We see the three tables containing the data, the spatial information, and the metadata of the datasets. And as we see, again, the rest of data is stored as external files connected to the link to the database with identifier. So this is a pretty massive database of data that was aggregated into the into our database. And next, please. And here we see an overview of the API architecture. This is a bit how the database talks with the other services. So on the left, we see the user, or the front end, where we see the data, visualize the data. And then on the right, we see the connections with the OpenAire gateway, to which we deliver some bibliographical metadata, and also like some previews of the datasets. Next, please. So yeah, here I come to the end of the presentation, and where we see also a bit of the future of the project. Next, please. Yeah, first I would like to stress over some features of the project that would help the reusability, enforce the reusability of the project. First, the flexibility. Despite being for energy, and EnerMaps is still, the platform at least, is still quite domain agnostic. Also, it's focused on geodata. It means that could be used for other things than energy, and it also gives a lot of flexibility, for example, in the development of custom calculation module. It's also a modular platform, again, thanks to the calculation modules, but also to the possibility of integrating new data sets. Finally, deployability. We have deployability that is quite simple, thanks to platform independent Docker services. And also we could think of the back end and the front end as independent, and so can be run separately, and one can choose, for example, just to run one of them. Next, please. So to go further with EnerMaps, of course, we could integrate new data sets, and so use the examples of the pipelines we developed to add the new data sets that are not yet there. But also like the development of the calculation models. And yeah, here should an example of the templates and the documentation that are in the Git repository. This is of course just for the developers, but that's an idea how the project could help like develop similar calculation models for other uses that were not foreseen in this during the time with the EnerMaps. Next slide. And that's my last one. We could also think of going with more platforms, so more a mapping platform, not necessarily for energy. In fact, the software could be just used as a data visualization platform, for example, by companies or public sector agencies, for example. And yeah, as said already, it's kind of domain agnostic. So this platform could also integrate non-energy data sets. And yeah, this concludes my presentation, and I will hand back the floor to Jakob. Thank you. And I'm available for questions, of course.
Thank you, Giuseppe. I see that the Q&A session is starting now, and that we have a bunch of questions. So I'd like to invite Alessia and Eric and Cédric back on scene, so that we can quickly address the questions that are there. Besides the ones that you were already quickly able to pose in the chat as a quick response, maybe the legal question on open science would be a first opener that I'd like to address to Alessia. So what would you give us as a hint, besides, of course, following the guide, to address best the legal problems on making a data set reusable, making it fair? How can you elaborate on this?
Yes, I think the basic concept that we shouldn't forget is that we should be as open as possible, as close as necessary. There are some kinds of data or that really cannot be openly shared for several reasons. So let's say the basic approach can be to use the CC BY or CC0 license whenever available, but it is not always possible. So it is important maybe that you shared with these licenses the metadata about the datasets, and then you can also make the data itself closer if necessary for privacy reasons or any other reason. Another key aspect, I believe, is that in some cases you can actually anonymize the data and publish the version that is anonymized but still useful for others to use. So in OpenAire we have the Amnesia service that does exactly that. So you can give it a try. I think I also see a question about the compliance, the compatibility among the licenses, and those can be checked via different tools that are available online. There should be one from the Digital Curation Center and also another one. I don't remember if it's provided by Software Heritage or another initiative that works on software and data, but I will double check and I will add the link to the chat afterwards.
Okay, great. That already gave us some feedback. And I see that there is some background noise. Sorry for that, but we'll see if we can get a hold of this. I think there was another question coming up on metadata, and maybe Eric, you can reply on this a little bit, and others can complete afterwards. How does this impact the scientific process? Because we often find data itself, but that itself doesn't answer the question. I mean, we need to be able to work with this. You said it in the quality check process. What were the hurdles that you saw on the data that you quality checked? And what would you give us as a takeaway message on people that have data but are wondering how to make the metadata on this?
Yeah, so basically, it was one of the main issues is basically finding like comprehensive metadata for a lot of the data sets. Many of the data sets either just had very basic number of fields, they didn't really follow any specific standard, or they just didn't provide any explicit metadata at all. And so obviously, I think like the bare minimum you could do if you have a data set is to, at the very least, provide some metadata following, an open license. Obviously, since EnerMaps is an open platform, we'll always be pushing for an open license like a Creative Commons or something like that, and have that attribute even for your metadata. And to stick with some well-known standard for structuring that metadata. So making sure you're including the essential fields. And I mean, for researchers looking for metadata or looking for data and are examining the metadata for a data set, I mean, the more the merrier. So like any details you can provide are basically, you can't go wrong just adding more. So yeah, I mean, as far as our experiences went, we had to fill a lot of the holes ourselves. And yeah, that legwork isn't really doable for a lot of people who have research projects where their goal isn't to fill in the metadata fields for the data they're collecting. So if that can be done at the publisher level, then that would be ideal.
Mm-hmm. So we have the question coming up regarding the standards. I think in the chat we had already Pietro Zambelli, who will be in the breakout session following our coffee break, completing also some links. I don't know if one of the speakers would like to complete on those. We can address those questions also in the breakout sessions later on. And I think the question was directly addressed to Eric again. So I don't know if you want to give a concrete standard on energy data that was the most useful for what you have seen. I think the discussion is on the on schema.org, energy/energy. We had some discussion going on. Or do you want to complete on that, Giuseppe, who has been working on the database, on integrating the data that comes after the quality check process to you?
I can just give a quick response. So basically, yeah, we used schema.org to structure a standard that we also basically designed ourselves. Yeah, Pietro was the one behind that, so he could elaborate more during those networking sessions, breakout sessions. But yeah, Giuseppe, if you have anything to respond to, but that's the basic justification behind it.
Yeah, from my point of view, I mean, it's not really related to energy. Actually, it's more like some basic needs of like know how the data structure, so that it can be reused in a pipeline to be stored in another schema. So maybe the need of a specific metadata for that are useful for that integration. Just a simple example describing the columns of a tabular data, and that's the example in my presentation about what the data package.json helped us doing.
And maybe you can add a word, Giuseppe, on update, because what always happens is that once a data set is there, it might get updated, and the work might start over again from your side, and except if it's well documented, I assume.
Yeah, again, so for the updates, that's also a similar problem. For example, before like updating like data, we need to check that the format is consistent for with what was there before, so that the schema didn't change. Otherwise, there should be like a manual check by someone. So again, also here, like the metadata describing how the data looks like is useful to do this check before that we can update the data in our site. And in some cases, it's not possible if the data has changed the schema. Then like some manual intervention is needed.
Yeah, and I think that's also, unfortunately, one of the key lessons that we learned is, even though we have only a relatively short project, those things happen, and you're ready to deploy again, and suddenly a schema changed, and you have to look into that manually again to be sure that you integrate it correctly. Those things happen, and that is a lot of work that needs to be done on a regular basis in order to ensure that the pipeline keeps working. I see one more question that was largely addressed, and I wonder if my panel here wants to just reiterate on this question, maybe to give you the context again. It was on legal metadata. We talked a little bit about license and compatibility issues already. Initially in EnerMaps, we wanted to publish 50 sets. I have identified 50 sets. However, on the platform now, you will find less. How did that happen, and what's the reasoning behind this? And it's often not, unfortunately, not technical issues such as being able to integrate via the pipeline the points. However, this legal issue came up several times looking on the license. I don't know if you, Alessia, want to give just a first insight on the license itself, saying, I mean, having data online doesn't necessarily mean that we can reuse it. So the redistribution part, it quickly gets important.
Yes,
it's often not addressed. Yeah.
It is important because we experience while analyzing these data sets, and maybe Eric and Giuseppe will tell more, that these data sets could be found online. But in fact, there was no license associated. So we didn't know if we could reuse it or not. So we tried to find information here and there, and we also contacted the responsible persons who we thought were in charge of the data sets. We contacted the projects that produced those data sets, trying to find a way in order to help them to
Yeah.
To share their data in a more fair way.
And maybe Giuseppe, do you want to complete on this success? Because in the end, it is time consuming on some data sets to at least get answers. But I think in others, I mean, it just went off to World Wide Web, and yeah, we're waiting.
Yes, I mean, I think that's a common project, a common problem for many projects. So I would encourage to have a clear license and a Creative Commons, for example, associated with the data. This really help everyone understand what you can do or what you cannot do with the data. Otherwise, just putting data in the internet and just saying that it's open doesn't really mean anything, or maybe mean by we couldn't use this kind of sentence for the purposes of our project. So yeah, I think it's very important that every data providers associate a clear license with their data.
So maybe wrapping up, I'd say, yeah, think about the data lifecycle from the beginning, because that helps you and all others that are behind you to have a clearer vision on what you can do and how to exploit that data. That's unfortunately one of those lessons that we learned sometimes the hard way, because we did not get answers on questions that we asked the data owners, and therefore we could not use in a fair way their data. Sometimes the answer was also no, you cannot redistribute. That also happens. That might be sometimes intentionally. So on that part, if you have data and want to share it, yes, think about it right away, which license, and reach out to us if you have pragmatic questions, as some of you already did in the chat. We're happy to share our learnings with you. With that being said, I would like now to hand over and thank my panel, first of all, for the great presentations and the answers that you all provided, and hand over now the microphone to the reminder of our training program. So I hope Giulia will join me now up on the virtual scene. Our training expert, I see you're there. Perfect. I think the floor is yours.
Hi, good morning. Thank you, Jakob, and good morning, everyone. Yes, I'm going to talk you briefly about the training program, which is having an event tomorrow. Next slide, please. So EnerMaps, on top of all these activities that the colleagues of the consortium showed on the development and the work behind, has a dissemination program. Tomorrow we're going to have this workshop hosted by the World Sustainable Energy Days in Wels, Austria. It's starting at 1:30. Jakob will welcome us. We'll show a brief introduction of the project, and then we will dive straight into how to use the tools that EnerMaps has developed. There will be a first part dedicated to the gateway that I will show you and guide you through, and then one dedicated to the data visualization tool, where Markus Hummel of eThink and Eric Wilczynski of Eurac are going to show you how to visualize the data on the map, how to use the calculation modules. There will be practical exercises, and the floor will be open for questions and answers. It will be an open meeting, so feel free to join us tomorrow if you're interested in knowing how the tools developed by EnerMaps work. And this is the link shown in on the slide. Maybe we can share it in the chat as well. It will be 2 hours and a half, very interactive. But in case you cannot join tomorrow, please remember that we always record our training events, so you can also watch them at a second time. Maybe I can also share my screen and guide you through the training material page of the wiki. I'll just share it now. Okay. Just a second.
Don't see it yet. Hopefully it will show up now.
Are you seeing my screen with the EnerMaps wiki?
Yes, now it's there. Great.
Perfect. So we're going to share the link to the wiki as well. There was a lot of work done by the whole consortium behind the wiki. The wiki works as a user manual. So basically, when you land, you can choose your language. There is a welcome page that explains how the wiki is structured. On the right here, you see there is a menu with a welcome page, the user guidelines, which explain how different users from different target groups could take advantage of the tools developed in EnerMaps. Then there is a lot behind the work of data collection and the different data sets. The tool functionalities are explained in detail, and the different layers, how to select the regions, what are the functionalities of the tool. Then there is a dedicated page for each one of the calculation modules and the additional functionalities. There is a section for developers, so how data is integrated in the tool, how a standard an empty calculation module can be used, because all the code behind the tools of EnerMaps is open access, so users can download it and reuse it. And then in the Learning Center, there is one page on the training tools for EnerMaps, and here there are links to specific videos for the different sections of the tool, and there are links to past training. So there is a space that is saved for the training we will have tomorrow. Please join us live if you can. If you cannot, come back to this page and rewatch the training. I will stop sharing my screen now. Thank you so much for your attention. I hand it over to you, Jakob.
Thank you, Giulia, for the reminder of the wiki, because I think that's really a key output also of this project. You have the really high level documentation on the website. You have the wiki that gives you the hands-on how to get started, and of course you have the tools, the code, etc. itself. But if one of those layers is missing, you quickly get lost because you don't know how to go on and work with the tools. So with that being said, if there are questions, please regarding the training event, address them on the chat as well. Giulia will be with us, so will give us a hint. Now we're almost at the coffee break. With that being said, I'd like to remind you that you need to change within the tool and go down from the plenary right to the networking session. Click on the networking session and then choose your session, either the one for researchers and developers or for practitioners and decision makers. Please, I'd suggest to do that right now so that we can meet in 5 minutes again online before you go to the break, because you might have to just choose technically, I mean, the microphone and so on, and check that everything is working. Normally behind the scene, we'll welcome you and be sure that you choose one of those rooms. In case you have technical problems, again, please use the Q&A and ask us so that we can help you and find the right room and get that working. Our experts are happy and waiting for you to share their knowledge. So with that said, I'll thank you all the people interventing, all the interventions that we have just heard for the input, for making this morning interactive and sharing the knowledge that we gained throughout the project. So I'd say we'll go now to the breakout rooms and we'll meet and start with a pause now. So see you at 10:10 in the breakout rooms to start the breakout sessions for the 2 different groups that are online today.
It will give strategic support to building owners regarding energy efficiency goals in the context of patrimonial protection parameters. Launching this project, we asked ourselves about the technology we will use. Our benchmark leads us to consider 3 ways. First was to develop a from-scratch solution. Second, to buy an off-the-shelf product. And third, to reuse an open source existing solution. Our needs of flexibility and robustness leads us to this third way. What we found in EnerMaps is a complete geoportal solution. It answers a lot of our interrogation about data shares, data protection, interoperability, scalable solution working on our servers with our databases. It's shaped with standard open source tools like Python, well-known libraries like Bootstrap, Leaflet, and a robust architecture based on Docker. It's also well documented with README in every repositories and a strong and active community on GitHub with FAQs and more. So we choose EnerMaps and it fulfills its mission. Thanks for watching and have a good time.
We can go to the next slide. So,
sorry, my fault.
Yes, thank you. Just to not have it on the loop for the rest of the session. Don't worry. So basically, what Arthur just told us is that EnerMaps is designed for reuse, and he was able to, on one side, adapt it fairly easily to Historeno. He was not able to show us a prototype yet because, I mean, as you have seen, the project itself published a last version maybe within a couple of days. He's still pulling the last updates into Historeno and making his example run. However, he already pointed out what are the strengths being open access and open source and having the code with the documentation available combined with the training material that allows him to customize the tool. And when we talk about customization, I think we also talk about the analysis that are possible to do based on this. And this is really what on the next slide I will now have. Pietro and Mustafa will talk about the different ones that we pre-wrote for you, the different calculation modules, analysis tools that are already there. However, you're free, of course, to write your own and be inspired of what you see here. So please, Pietro and Mustafa, take over, and the floor is yours.
Okay, thank you, Jakob. So yes, we were in charge to develop some of the functionality that have now available on the platform that is online. One of these was a tool to visualize and see the heating and cooling degree days scenarios, how the heating and cooling degree days will evolve over the years. So to do so, we use the simulation provided by the Cordex consortium. The Cordex consortium is consortium that is collecting simulation data, different climatic simulation data, and is providing the minimum and the maximum daily temperature over different under, let's say, different conditions. So they are considering 5 different scenarios. And they are using the Eurocordex is basically downscaling the global climatic model into a regional climatic model for Europe. And so they are working to provide this downscale model that is with a resolution of 12 by 12 kilometers, a raster resolution, where basically we have the daily minimum and maximum temperature. The different models cover different time periods. So like the historic scenarios is covering from 1950 up to 2030. So they are considering, let's say, concentration of CO2 that is what we have measured on the atmosphere. And so we use this data to compute the heating degree days and the cooling degree days. Here are reported the formula where so we use the minimum and maximum daily temperature to compute these values, and then we aggregate to monthly and yearly values. And we use a base temperature to understand, to compute these heating degree days. If I may, sorry, where it is now. Yes, that one was, sorry. That one. Yes, so we use the Aerocortex simulation that are available here. And as said, we have different scenarios. In particular, the IPCC is providing these scenarios with different representative concentration pathway over the next years, let's say. And we use different base temperature, because if you look at the, let's say, building energy signature, to the energy signature of a building, we can identify a temperature where the heating, or in this case, the cooling, start working basically over a certain threshold. So all these parameters are available on the calculation module, and so to do so, we compute the heating degree days and cooling degree days and aggregate everything monthly. And the data set is also available, sorry, to a dedicated repository where we explain a bit how has been performed, and also there are few information how to contribute. And you may find all the GeoTIFF data here, so as a raster map. Later, I will put also the link into the chat as well. So what the model is doing, where it is now. I'm stuck here, sorry.
Maybe it's just another window that you might be already in presentation mode. I don't know.
You're right. Sorry for that. I should just pause. Okay. And now, sorry for this. It's taking some time. Come on.
It's back, but at the first slide. So,
yeah, unfortunately. Okay, so the calculation module that you can try on the web basically is using the dataset that is in the repository that I just showed before. And based on the geometry that you select, here, for instance, is a city in Italy where Eurac is, and compute the centroid of the geometry and query all the series of monthly and yearly data set to return to the user the heating degree days and the cooling degree days that are foreseen for the coming years, based on the simulation data that are provided by the Aerocortex consortium. And then, so here you can see that you can select scenarios available on the Aerocortex dataset, and select the base temperature that you want to consider for heating degree days and cooling degree days. And then you will see the data, basically, the yearly values and the monthly values as well. The information, you can also download the data and the graph from the user interface. And of course, if you want to have the complete control, you have your the complete data set available on the web. Then, based also on this information, we built refurbished race scenarios, and the idea here was to integrate the data set. So we use the heating degree days and cooling degree days for the whole Europe compute for the previous calculation modules. Then we integrate the data from the building stock dataset from the EnerMaps project that is on national level, providing the number of square meter per building category, etc. And we use the characteristics defined by the Tabula dataset. Here is just a screenshot of the Tabula dataset. And then we use the EU population at municipality level to as a proxy to the building, basically, to then be able to compute the energy that you might save if. So this is the interface. Again, we select a region. Then we can select the scenarios for heating degree days, cooling degree days, and the reference years that you want to select, as well the base temperature and the for heating and for cooling. And then here you can select the apartment blocks and the start year of construction and the end of year of construction that you want to consider. We weren't able to get directly the class because even in Tabula, each nation have different classification of the epoch of construction. So because it depends also by the history of the nation. So some of them end, or I don't know, in 1950, some other in 1945. So there is no consistency for the whole EU 27. So we just let people select the starting year and the end year, and the tool will select the classes that contain the year selected by the user, basically. And then it is providing the savings that are foreseen if you apply a certain refurbish. So we use the Tabula data for the basic refurbish rate. The Tabula provide the information about the performance with a basic refurbish that you might reach for a certain kind of building, and what you can reach if you apply some advanced refurbish. So we use this information and let the user select different percentage. So this is all for the calculation module. And I leave the floor to Mostafa.
Thank you, Pietro, for presenting the first analysis tools or calculation modules. Well, the next calculation module that I would like to present is the calculation module, district heating economic assessment, which its objective is to identify the potential district heating areas and their associated network cost. And here the focus is given to use open data sets that are available on a European level, on EU 27 level, with high resolution, relatively high resolution, 1 hectare, which are coming from other European projects. Basically, it is the data set on heat demand, annual heat demand, and also gross floor area, which is used for calculating plot ratios. Another objective of the calculation module is to study the impact of different parameters, economic parameters, but also technical parameters, and such as connection rates and also construction costs. as this is a little bit different across Europe in different member states. So we gave this focus to be more specific when it comes to the calculation for every single member state. Next slide, please. Well, the main idea behind calculating the cost approach is levelized cost approach. And to do so, we have two criteria. So at the first stage, we need to identify certain regions as potential district heating areas or coherent areas. And for that, we have certain requirements. First of all, the heat demand in those regions should be above a certain level defined by the user. And secondly, the average grid cost in those regions also may not exceed the given value by the user. So once these two conditions are fulfilled, then we identify those regions as potential district heating areas. And accordingly, the levelized cost of grid will be calculated. So it's basically the sum of the cost over the lifetime divided by sum of energy produced over the time or delivered over the time that the grid is in place. One additional aspect that we added compared to previous studies in this tool was consideration of service pipes, basically the connection of distribution pipes to the buildings, which was not available in the previous studies, but since some recent studies published information on that and also did some experimental and empirical tuning on those values, we were able to integrate service pipes into the calculation module as well. So the whole idea works around the open data sets that I mentioned, annual heat demand and also gross flow area, but also the concept of effective heat. Next slide, please. Which basically describes the relationship between a given land area and the length of the district heating trench, which is located in that area. Once we know this relationship, we can have a good estimation of the pipe cost. And for that, as you can see in the left figures, there are two graph showing the scatter diagram of different network and situations in three large cities in Denmark. So based on that, two separate formula has been extracted from those two graphs, where you can see that what is this relation between plot ratio and effective heat. And here again, special focus is given to areas with low plot ratio, so the sparse areas, as they are also relevant when we are thinking of expanding district heating areas. In context of this calculation module, of course, those single areas alone are not very important, but when they could be considered as expansion areas, then they will become relevant. Another point which was relatively important here in this calculation module was consideration of market share or connection rates. Since being in a dense area or sparse area alone does not say much unless you know what is your target or which target you have to set to have a economical district heating system which still makes sense to build and develop. And for that, we also developed a curve which basically fits to the areas that are rather sparse, because in more dense areas, as the figure on the top left shows, when the plot ratio goes above a certain level, then it doesn't matter how much you connect. Always you need a certain amount of trench length or pipeline length to be built in order to deliver heat to the customers. So these aspects also specifically added to the calculation modules, and the aim is to cover also those sparse areas better than before. With that, I would like to go to the platform itself. I share my screen quickly. I hope you can see my screen now.
Yes.
Great. So once you are in the platform, first you need to open this calculation module tab and select the corresponding layer. And once you do so, then it's necessary to take a region which is relevant for your case. I do not change here anything. I stick to the standard one and consider Berlin in Germany. There is an option to select member states. Of course, this is relevant for construction cost, as there are like certain parameters in the background specific to each member states. There is also the option that user gives it him or herself. Then there are two types of analysis that can be done. So either you go for specific network costs to get the values in each hectare element, how much it could be roughly, or you have the option to select areas that can be identified as potential district heating areas. Certain parameters for defining conditions for identification of potential district heating areas, and also economical parameters, lifetime, connection rates can be given as input. So pretty full control over the calculation. And as you can see, there are regions that I can also show the legend here. There are regions which are a little bit darker. Those are the regions which are more suitable than the other ones for the district heating system. And a set of indicators are also provided, which gives an idea of how much demand can be covered over the investment period, over the lifetime investment period. What would be the average cost for the identified district heating areas? And to make it more clear which part of this area can be identified as potential district heating areas. So with a given condition in this example, we can see these blue areas can be still be considered as potential district heating areas. Yeah, with that, I think that was a quick look into the calculation module of district heating economic assessment, and I give back the control to the Pietro.
Yes, I have chance to read a bit the chat. I see a lot of questions about the tool, why we select what, etc. Yeah, I think we try to find the common denominator of knowledge in terms of language. So most of the institution involved on the consortium were fine with Python. So we simply go for that, and also there were already quite a lot of libraries available to work with both spatial data and also using like for the model developed by Giuseppe that, if I'm not wrong, use TensorFlow. So I mean, there were quite a lot of library ready to be used. So we simply use that. As far as I know, we didn't directly link to any C or even compile code directly, but we just use library that did this interface for us, basically. Concerning the code is in EnerMap. You can see here. You have all the Docker compose that are combining and that let you run the platform on your on your system, basically. So just to give you an idea how it works, here are quite well documented all the things. The calculation module, so if you want to add new functionality to the platform itself, is under the CM directory. Again, here you find a README on how to build your calculation modules, how to structure the code, etc. Of course, you have some examples already inside, so like the multiply one. The general idea is you have the worker that is publishing a REST API using the Flask framework in Python. The GUI is generated at runtime reading the schema.json file. That is just a JSON file with some properties. Again, here we are using another framework that is exactly doing this. So here you see a demo, for instance, where you have some variables and that are generated by this schema. So where you just put the field that you want to display and the type of the object, etc. Okay, and this is generated at runtime based on the description. So each calculation module is free to define the inputs that they want to receive, basically. I say the worker is providing the REST API to certain to your module, and then within the folder you are free to then structure the code as you like in a dedicated file, or you can build even a dedicated folder. Basically, the developer have to build a Docker file and that execute the Flask instance and expose, let's say, the service to the platform, and that's it. Okay. So
maybe I can just complete just your comment. Thank you for the details, Pietro. Just want to point out that we are here working on a web service, basically, and the goal is to have something more or less interactive going on. So I saw in the chat some references to supercomputers and so on, and code that's written in C++. Of course, the integration of the results of that is possible, because as long as you can georeference, for example, the data, you can upload it in a database and have it on an explanatory basis online. But the goal with this platform is not to be able to launch this code, wait a week and get the result, and then be able to explore it, because it would require an additional interface for the user to understand what's going on in the background. Here you're on a calculation module that does short calculations, so that the user can click and see the results and explore them right afterwards. So that changes a little bit the focus. We had those problematics in the old project, in the big sister project. I'll talk about this a little later. In hot maps, where yes, calculations suddenly took time, and the user behavior, especially if you're not people that code, is like, why is this freezing? And then they launch 5 times the calculation instead of waiting that the result comes in. So there's also some user management to be taken into consideration. Here, the goal was really more on the displaying, sharing, and having simple analysis tools that can run something. And if that gets more complicated, it's probably more interesting to have an intermediate layer of pre-calculated results that can be then explored further.
Yeah, and that I can add one more point. I mean, the focus of the data management tool was to visualize available open source datasets and show that if there would be access to such data, there is possibility to do manipulation on that and extract additional indicators and information which further can be used for certain purposes, like estimating demand or estimating the cost of district heating, as I showed, or look into heating degree days and climate change scenarios. So these are the things that we should feed to the user as an idea of what can be done with open source datasets, but also motivate the community to share more data with open source licenses and also FAIR principle.
And I think you're making the bridge, Mustafa, towards another question that's here on data semantics slowly a little bit. And I'd say the problem, the basic underlying problem on ontologies, metadata standards, and so on, is that for the moment there is not the standard, so we are kind of forced to make another one. So if you have 10 now with EnerMaps, you have an 11th one, and you can learn from this, and because we can tell you why we did different things. However, we cannot unfortunately provide this solution, because having a standard would also mean that the whole community accepts it and adopts it, which is not really the goal of the project. But of course, we explain, and we're there to share our lessons learned and explain people why we did it this way. But we cannot we cannot go any further than this at this stage, because we are not a norming, we're not an organization that gives out those norms.
Yes, and we also look at the ontology developed by the Open Energy Platform as well. Actually, it would, at least it wasn't always clear to me how to practically use this ontology to our data set. So we have this question, and yeah, it wasn't always easy to apply. I think this is also a threshold we should reach, in the sense that we have to be precise, to semantically precise, on one end. On the other, we also need to provide the information that are understandable by an audience of people that is large enough. Otherwise, it will be never used. And I think this is also a compromise that that we have to reach somehow.
Yeah, it seems that the data integration and also standards is a point that a lot of people are interested in, and I think yeah, maybe this is a message that we should take home today, that there is more discussion in the community. There's more need to discuss about these topics in the community. We used certain methodology, as Jakob already mentioned, and Pietro. Yeah, and we showed that it's possible to work with them, but yeah, always good to have those kind of discussions, improving the whole standards, looking into data sets. Good.
I think, Giuseppe, thank you for the answer on the size of the database. So yes, about 1 terabyte total is in a Postgre database. So yeah, we're talking about quite some data out there. And yeah, thank you for the links to complete this. I'm going through the chat on hosting EnerMaps. We'll talk about this in the next one. That is always a crucial question. Some of the services will be integrated into OpenAire. We are finalizing this so that we can write a blog post about that. Of course, what remains a big question is package updates and so on. As long as it doesn't break anything, that is rather quickly done. You can go on GitHub basically and republish a new version. That's quickly done, but sometimes those updates break past existing code, and depending on the effort, we'll have to see. We'll talk about follow-up projects, and as I said, Historeno, as we said in the introduction, is already one project that takes it over. So the goal at this stage, or unfortunately at this stage, we don't have this solution yet. We have other projects that keep using the code and that can contribute partially through using it into keeping it update and running. But so far, there's not much more than this around it. We have had the same discussion on hot maps, and luckily the next project comes now that is taking this up. Yeah, it's always there's not a one solution fits all, I think, and Mustafa, you have also been active on that. I don't know how you would comment on this question. It would be interesting to see also your background on that.
Yeah, for me, it's a sign that we are on the right direction, seeing that there are interest, and also we have had successful examples. At its time, HotMaps was a great successful project. Now EnerMaps, and the procedure continues with this new project, and yeah. That's the thing at this stage I can mention. So the other project just started, so I cannot say much about the developments there. But yeah, this will continue for sure.
Okay, then I'll go over to the next one. Did I miss one here? We had this. We don't have any relation yet to software inheritance, software heritage, but thank you for pointing this out. We're learning on this, and we have to see how maybe some of those ideas can be integrated more in the open source community in the general one. I think that's a good point. We'll have to explore that.
Yes, may I add something about software heritage? Because software heritage is one of the sources from which we get the software that you can see in the EnerMaps gateway. So the connection, let's say, between software heritage and EnerMaps is via OpenAire at this point, and this allows the gateway to have links that are resolvable, because often when you mention old projects on GitHub or on SourceForge or Google Code, they are not resolving anymore. So thanks to software heritage, instead, we can still reach to the original source code. And this is, of course, a great help for reproducibility of research activity.
Thank you, Alessia. Do we see any more questions on that? Metadata, I think, I don't know if you want to add something to the previous discussion already on this, Pietro.
Yes, so as said, we consider also the open energy platform metadata. It wasn't actually really clear how to apply this on our context. And so this was the main issue to use this. I'm looking at the example that is available now. But yeah, I still think the ontology of as it is defined it wasn't always clear to me how to apply this on our case. So this is why it wasn't used, basically.
I think that's also a good point of standards. If you over standardize, afterwards you might have trouble in applying because it's so general that it's not clear anymore. So yeah, it's always an ongoing discussion, and unfortunately we have not found neither the solution, but we have contributed our part and have a working example online. So exactly, I think Stefan Ferenc in the chat says it. There is still work to do, and we're waiting for your input so that we can discuss that and learn from that.
Yeah, and on the other hand, yes, we use the data package in a repository, so we can also think to improve the metadata of the data package so we can, I mean, we can add the new ontology to the dataset itself, or we can receive a pull request to add this information or metadata to the repository as well. So yeah, I think it's not done, but and I agree there is still work to do for sure, but that's it.
I'm just looking at the timing a little bit. We have another couple of minutes, 2-3 minutes before we go back to the plenary. If there are still any questions, please feel free to reach out. You have, after the closing, again, the possibility to talk with us. You'll see who is in which room. So
yeah, it is not really clear about to me the question about the heritage, etc. I mean, the code is on GitHub. Yes, it's possible that GitHub will be closed, but still is a distributed system, so everyone can have a copy, and at least all the developer of EnerMap have a copy on their computer. So and we can easily republish the code on other platform equivalent, just hosting Git. So I don't know. I don't see really what is the concern on this exactly to me.
If I got it right, and my interpretation is, I mean, as it's project-based code, the project ends. That's the definition of a project. And what happens afterwards, especially if somebody really likes it and who's going to take this over, that is a key question. And as Alessia pointed out, that could be a solution of having a software heritage, I guess, yeah, doing it and being more active. We have still a couple more months within this project to see on and what are a couple of those pragmatic solutions that we can find because I think the new projects, even there are some, always have a slight different focus and will develop some of the parts and maybe not others. So an overall EnerMaps maybe will end, but parts of it will probably be retaken and go on. That's kind of the challenge of that. This is why also in the documentation we referenced hot maps, because it's, I think, a huge inspiration. I'll talk about this now at 11 when we go back to the plenary. In case if there is not much more, I'll keep the timing in mind. And yeah, if there's one more last comment or question, please now. Otherwise, you have to wait until we go to the network session, so where we can. Yeah, thank you for the comment on heritage. That's the first part. It's archiving to have something running. That's true, but we're also looking forward to other people that are taking over and have maybe the resources to keep things alive. So it's always the spread, yeah, both. So as it's 11:59, I would suggest that we all press the leave button table, which is on the up high over the screen, so that we can go back to the plenary and see each other there for the wrap up. Thank you very much, Mostafa and Pietro especially, and all the others that have discussing with us. Thank you, and see you.
See you.
You're on the other side.
Thank you. See you.
So welcome to this breakout session dedicated to how EnerMaps can support practitioners and decision makers. More people might join along the way, but I would like to start with a short introduction. And again, as in the plenary, please use the chat if you have any questions. In the breakout rooms, you can also unmute yourself and ask your question directly. And I think that's all I need to say for now. So perhaps as a general introduction, I think from the very beginning of the project, the idea was to address the problems of different stakeholders. And we early on, we asked ourselves the question, who is EnerMaps for? EnerMaps was designed to be user-friendly and support policymakers, professionals in the energy sector, researchers, obviously, as well in making informed energy decisions. And so this was supported all along the project at multiple decision levels. Essentially, what you find, as you saw previously, in the plenaries is, and I'm switching slides, is decision data and tools for all decision levels. So we have data at the European, national, regional level, at the different statistical scales, spatial scales, and these data sets and tools help prioritize some of the mitigation policies, such as how to deploy renewable energy technologies, where building retrofits should be done first, and so on, as well as, and this might be new as well, is to the data, it includes also climate data sets, which can help in adaptation policies. And that's at sort of a large scale level. At the local, the urban level, or city level even, and where some of the analysis tools work. And we can clearly see, and I'll show you some quick examples, and where, for example, district heating networks would need to be developed and deployed, partly to substitute natural gas, for example, in urban context, and evaluate the different potentials of these technologies is something that the EnerMaps visualization tool can also do. One simple example, if you look at the visualization tool, you might focus on an urban area. This is close to Lyon in France, where you can simply extract the data for heat demand, which looks something like this in megawatt hours per hectare, and identify where you would concentrate efforts to provide renewable heat and cover the demand. So this is something that the EnerMaps visualization tool can easily do for you. There's also the question of adaptation policies. Here you have the map with for the same region with the fraction of days with above average temperatures, and it's interesting because you can also compare this and for the same region calculate the historical, but also the future heating degree days and cooling degree days. So this gives you a sense of what to expect. If we look, for example, here at cooling degree days, we see that starting in 2030, based on the current trends, or with the year 2032, we might see a big spike in cooling degree days, and so the need to adapt will obviously get greater and greater. So these are just two examples. Obviously, there are many more. What's interesting with EnerMaps also is that it really supports decision makers or policy makers at every stage of the policy cycle. And you can find in the resources in the menu on your left, you can find a link to a policy brief, which is shortly described here. So EnerMaps can help in setting targets, so formulating realistic or ambitious target in the medium and short term, with the access to data and its visualization. It clearly helps implementing the policy, so building support across a municipality, a region, a nation, also across different political factions maybe, and visualize some of the impacts that these policies can make, possibly to use against opposition. And I would say where EnerMaps takes its full potential is in monitoring the evolution of different policies. As was presented earlier, we can integrate new data sets, calculate indicators, and compare the simulation with new measurements. So this is really a strength of EnerMaps. And in addition, evaluate some of the benefits, costs of energy policies, of energy technologies even, in particular for district heating networks. There's a dedicated analysis tool. And the evolution, these evaluation can be accessible easily to non-specialists. So just to come back to the motto of the EnerMaps, empowering your energy transition. Essentially, EnerMaps supports energy transition, innovation and initiatives by improving access to energy-related data. And making it user-friendly so that everyone can do so. And mapping both on the supply side, the potential for energy sources, in particular in urban centers, as well as the demand, obviously at different scales, urban, regional, and national. And this was made possible also because the EnerMaps tools were developed with the help of social innovation experts. At the beginning, as it was described earlier, by identifying and specifying the needs of the stakeholders in energy and energy-related data. Also in the selection of the data and its validation, and starting now, but also it started already in disseminating the EnerMaps tools. So that's a quick introduction to how EnerMaps can help in supporting decision makers, and I see that we're between us, I believe, but I would still like to introduce one of the social innovation experts who followed the project with us, Ina Karova. She's a long-term project coordinator at the Energy Agency of Plovdiv in Bulgaria. And she's been involved in sustainable energy planning for more than 12 years now, supporting local authorities in shaping their future development. She manages projects with both advanced energy technologies as well as novel social approaches to showcase sustainable and resilient futures. So thank you, Ina, for being with us and for following the EnerMaps project all along. Perhaps to start with, to give an idea of how EnerMaps can contribute to your work, I'd like to ask you a few questions, but if you want to say a few words first, please go ahead.
Yeah, thank you for inviting me to the final event. Thank you a lot for inviting me to be a board member for your project. We know each other for like 3-4 years now, since the very beginning of the project, and it's been an exciting journey to be with you. And as far as I know, and as far as I've been in the flow in the project, I've seen your enormous efforts to make it work and to bring it to this amazing level of readiness to be integrated into the work of other practitioners and other developers. I'm really happy to be here and today with you and to say a couple of words on the tool and to probably talk a bit more with other practitioners of how this tool can make their work and life better and easier.
Great. So perhaps to start with, could you briefly describe your work and the role of the Energy Agency in Plovdiv?
Yeah, so for those of us in the session, I'm Ina Karova from the Energy Agency of Plovdiv. I've been in the domain of sustainable energy planning for more than a decade now. And I've been working both on European projects and on national projects in the field of sustainable energy planning and introducing different policies and technologies so that we have better energy efficiency and increased production of renewables. At the Energy Agency of Plovdiv, the sustainable energy planning on local and regional level is one of our main priorities of work. So this takes big part of our time here at the office, and this is a day-to-day activity that we are running. We are doing it for local authorities, for regional authorities. Sometimes we are consulting on national basis. We are taking part in different policy processes on local level, lobbying for different policies to be considered and taken into account into strategic documents like urban development plans, energy efficiency strategies and action plans, environmental action plans and strategies, climate documents as well. And so our work is both on the practical side, where we work with data and we try to process and transform data in a lot of ways so that it is easier for the policymakers to understand it. And on the other, we're working on the policy level, where we take the numbers, show them as proof that one policy is good or is not good at all, and we try to convince the policymakers and the wide public that whatever we are doing in the energy sector is good for them, or on the other side, that's not a good idea, let's not do it. Let's not do it. So at the Energy Agency, we are dealing with a lot of things, sustainable energy planning. We do sustainable energy communities, smart cities, energy education, transport and mobility, energy renovation of buildings, and so on. So there are a lot of activities, but today we're just talking about the energy planning thing. That's, in my personal view, the basis of all interventions in the energy sector. And so to say, this is the basis for all interventions in the domain of climate and environment as well, because the energy comes from resources that are, like we say, natural. Some of them are limited, others are not limited. So we have to take into consideration that the energy we consume actually impacts a lot of other domains, and we have to take into account these multiple impacts that we are having. So yeah, probably that's in short on the work we're doing and how we relate this work to the EnerMaps tool and the EnerMap services and products. So we have a lot of hands-on experience that we can relate to in this way.
Would you say in your in a sustainable energy planning, the challenges for in Plovdiv, is it more around building retrofits or transportation? You cover them both, but is there a focus at times on one or the other of these challenges?
So the challenges here in Plovdiv and in our region in general, there are a lot. They're very, very indicative of the challenges for all Bulgarian municipalities, by the way. We face aging building stock that is in need of renovation. And when I say renovation, it's not just insulation and new windows. We have to think and act ambitiously, and we have to take actions to be energy independent, self-sufficient, or even beyond that, presuming. And we have to involve and to mobilize the citizens, because the largest share of the building stocks is actually private. And if you don't mobilize the citizens to renovate, there's no need for that. Transport is the other sector that is significant here. We're the second largest city in Bulgaria. We have a lot of people commuting to the cities. We're a big hub in the southern part of the country, where we have private transport, public transport, business transport. Everybody travels here in and out of the city. The city is ancient, so to say. We have small streets. We cannot change the street traffic. We only need to manage it and to change the attitude of the people traveling inside and in and out of the city. So this is another big challenge that we are facing.
Yeah, and you're not alone.
Sure.
Perhaps if you can describe a bit more how EnerMaps could help you, or how the energy data that it provides could help you in addressing these challenges, I think that would be helpful.
Yeah. Well, in first place, just to say a couple of words on the challenges related to data in general, and that we are facing them every day in our work. The first thing is the lack of data. It's simple. We need a lot of information and a lot of numbers to make the calculations and to provide the evidence that some policies may work or they may not work. But for this purpose, we need data, we need numbers. And usually it's just not there. We don't have it in the public domain. It is difficult to access this data. It is difficult to cooperate with public data providers, for example, energy utilities, homeowners, building managers, fuel providers, in the case of fuels and transport. Everybody has a piece of the data that we need. It's in different formats. If it is in different places, it has different granularity. Sometimes they don't keep records of data that we may need, and it's extremely difficult. Each data set is so specific, and each number that we need is so specific, so unique, that it is difficult to collect each and every piece of data. It takes a lot of effort. Then you have the level on where you validate data if the different data sets are like synchronized and they have the same granularity, the same units, the same conversion factors and rates. It's a very difficult task to align all the data sets. So far, EnerMaps provides us with information, with data, with numbers that we usually can work with, and it's just one place where we can go and get that information. The second thing is that when we don't have the data, or we have very poor data sets, is that we cannot apply the calculation methodologies that we use. I mean, when you use poor numbers, you get poor outputs. It's like cooking. If you don't use good vegetables and ingredients, your meal will turn out to be something not really tasty and good, so to say. So it's basically the same. When I came across the EnerMaps tools, it turned out that some of the calculation methodologies that you're using, that you've embedded into your tools and into your software and platforms, actually work for us very well, and they're very similar to the things to the calculation methodologies that we're using. So that's important. That's another thing. When we go to the third step of the process, so when you have nice data, you have very reliable calculation methodologies, then you have good inputs. These are numbers that you can present to decision makers, policy makers, to different stakeholders. And here comes the challenge of the experts. We see data, we see numbers, we understand them, we see the patterns. But the normal people who are not experts in the topic, they don't see it. They don't really digest the information as quickly as us, and they need a shortcut. They need some way to have the data presented, or to have the data visualized on a map, on a chart, on something that they can digest quickly, so to say. And here comes the problem of visualizing the data. And EnerMaps also provides very nice maps with colors and figures and so on, that makes the numbers extremely chatty to the public, to the audience, and makes the process of explaining numbers for us, the experts, extremely easy. And when you have these tools, you can go to anyone and just say, okay, I have this analysis, these calculations, these numbers, and they say this and this and that. You can check out the graphs and charts and understand it yourself. And it is easier because usually the policymakers, stakeholders, they need that information that is digested for them, and it's a shortcut for them to understand what the numbers say. This is extremely useful in the EnerMaps tool. And finally, the last part is the policy-making process, where we come to present different calculation scenarios, different actions in a different way. And so we need this wide range of making the output numbers different and popping out, and the positive scenario to pop out of all calculations. And this is a way for us to provide evidence that a policy is good enough or not good enough. In general, we need ambitious policies. Nobody wants to go beyond their comfort zone, and ambition is just about that, to be outside your comfort zone. So when we as experts are using tools that are precise in their numbers and calculation methodologies, when they're chatty in terms of their visualizations, it is easy for us to give a very good rationale of why a scenario is good or not good. So in general, yeah, the challenges that we are facing are overcome by tools like EnerMaps. And if I have to kind of inspire you to go and see it for yourselves, I would urge you to go to click on platform, around with it, see how it changes, try to use it with your own case, and just explore it. It's good enough for our work.
Yeah, very nice. And perhaps one last question I have is regarding the how perhaps civil society can get involved. We saw in earlier this week in the publication of the latest IPCC report that sufficiency is a big part. So individuals can play a big part in reducing emissions and changing the way they use energy. Do you think tools like what EnerMaps provides could also help civil society individuals in making changes, or in being better aware of the changes that are needed for the energy transition?
So I've been for more than a decade in this domain, worked with citizens, and it's so difficult to work with people because everybody has their own peace of mind, and it's difficult to kind of navigate between opinions and to mediate between the citizens and, for example, the local authorities or the authorities in general. My impression is that our society gets more mobilized from year to year, and they get more active. They realize that they may be active actors on the energy market, and that they can take the things in their own hands, be producer of energy, for example, be a self-consumer, take part in an energy cooperative, and so on. So this trend of citizens getting more active on the field brings us to a point where they actually either come to us with specific ideas of what they can do, and the question, if they do it, would it make sense? Or they would go to the internet, click here and there, find a piece of information they're looking for, get inspired, and again come to us with this specific idea that they want to implement. And here comes the role of tools like EnerMaps, that they're easy to use for the final user, as long as you are well aware of what you want to do. It is easy for us, the experts, to really make very fast and concise estimations of these citizen ideas that we are getting. And again, it's a good evidence-based way to make decisions. For the citizens, usually we have this attitude that they want to be energy independent, not to rely on the energy provider in the domain. They want to be off-grid all the way. This trend has increased since the COVID, to be honest. And I guess that people are trying to untie themselves from traditional energy sources. And the question there is, if they invest in something to make them more energy independent, would it make sense in the long term? Would it achieve the financial impact? Would it achieve their environmental considerations, and so on? So basically, the EnerMaps tool may be a very good shortcut for both the citizens and us, the experts, to give the right answers to the citizen ambition to be energy independent.
Very nice. Yes, that's a very good point, and I'm hoping that with the dissemination of EnerMaps, we get more feedback also from individual and from civil society organization who find this useful. Anything you would like to add in terms of either between your work and how EnerMaps can help, or how you see EnerMaps take place in the energy transition more generally?
Well, in my work and in our work here at the office in general, we're using a lot of tools and different tools. Usually there is no one-size-fits-all solution. I mean, when we are getting to a case, we have some specific case to work on. We need to customize our methods and approaches. From what I've seen in the EnerMaps platform and tools and calculation algorithms and so on, it provides a very good way for us to work. It answers most of our demands for work, and definitely it has the potential to expand, which is something that probably I need to tell you on consortium level as a team that probably you need to expand somehow. For the users that come for the first time to this tool, it is important to know that it has its own nuts and bolts. You cannot just go to the platform, click here and there, and get it quickly how it works. You just have to be very diligent when working with the tool and find its features that suit you best. You have to dive into it and to really be very conscious of how you're using the different calculation modules so that they work for you. Usually people have this attitude of going to a platform, for example, or to a software. They click here and there. It seems a bit difficult to them, and they say, okay, that's not for me probably. Actually, EnerMaps is for you. You just have to be very, very diligent when working with the features, and you have to read the manual probably, because nobody really reads the manuals. That's one thing. And you asked about the energy transition. Yeah, I mean, do you want me to talk about Plovdiv in general? Because the energy transition here is like takes eternity. But yeah.
Why not? Or maybe we can keep this for later, because you pointed a very good issue with EnerMaps itself. And there's one part that we're about to publish, which I would like to share now for about 5 minutes, and then we can discuss again. One of the objectives of EnerMaps was to also increase, also improve the access to energy data. But clearly this is not enough. And we also wanted to increase what we call the discoverability of our datasets, the datasets on the or the featured datasets of the EnerMaps gateway, or the dataset in the visualization tool. And so we constructed a few data stories. We called them story maps. And I would like just to give you a few hints of what they look like. I'll share my screen again. I think you can see it now. And so the story maps or data stories, essentially the objective is to improve data discoverability and maybe challenge also some of the energy cliches that we have, both about energy supply and energy demand. And so we thought of them as short articles that people can read on their smartphones or between two meetings and so on. And also as a way for non-specialists to get to learn a bit how the data sets are organized, how they can be accessed, and so on. we went through a sort of brainstorming process and identified 3 issues that seem to be relevant in the current debate around the energy transition. One of them is, can economic growth be decoupled from energy use? So how strong is the link between economic activity and energy use? Another one is how energy supply security can be achieved with renewable. There's a lot of discussion around the scarcity of energy at the moment for many reasons, which I won't go into too much, but this is clearly something that needs to be addressed. And also why solar energy, solar thermal, solar photovoltaic, can considerably increase Europe's energy self-sufficiency, as well as increasing the share of renewables in the mix. Just to give you a short overview, one of the data sets in the EnerMaps visualization tool is this energy efficiency indicator, which was also compiled from an H2020 project, Odyssey Muir, where you have the data for 1990 here and the data for 2014. And so this is an energy efficiency indicator, so it's in megajoules per monetary unit, in this case US dollars. What you can see is that clearly there's an improvement in this energy efficiency indicator over time. So the colors are getting darker, and so that's good news, obviously. It can mean different things. Obviously, the economic activity has grown over time, and so that improves the energy efficiency indicators, but also energy use has changed. In terms of, if we think of the climate issue, unfortunately, it hasn't changed much. Our dependency on fossil fuels, and this is another data set in the visualization tool. This dependency hasn't changed over time. So we're still more than 80% dependent on fossil fuels. And clearly that's the main issue. So it has increased, well, fossil fuels have decreased at the industry level, partly due to outsourcing, but has increased in services and transportation, so that compensates a bit. One of the good news on the other side is that electricity use in a household is stable, and in some countries even decreasing in absolute terms, despite the increase in demographics and the number of households. So that bodes quite well in the energy transition, when we know that electrification will be a big, is necessary for electrifying some of the uses that currently depend on fossil fuels. So can we decouple from fossil fuel use or our economic activity? This is obviously the main challenge of the energy transition, and we can see it quite easily with some of the data sets in the EnerMaps visualization tool. We also look at energy security and the share of renewable in gross final consumption. This is also a data set you can see in the EnerMaps visualization tool. What's interesting is that the numbers are different, north and south, east and west. In Europe, Germany, France, and Spain share more or less comparable level of renewable energy in final consumption, but also the potential for renewable supply is different north and south, east and west in Europe. And so that's something that we can also see in the maps, that the EnerMaps visualization tool provides. And especially this complementarity, which we know quite well by now, between solar and wind. So as long as we have ways to transport the energy between the north and the south of Europe, the chances of default in supply are relatively low. It was shown that there are very few days when the sun is not shining in the south and the wind is not blowing in the north. So that's something that can be seen quite easily. We also wrote a story map on the potential for solar power, and what you see here is 2 different ways that the sun can be harvested across Europe, either by using your typical rooftop inclined photovoltaic panels, or with larger system tracking the sun across the day, during the day, and perhaps potentially to increase the supply of renewable electricity in the winter when it's needed for heat pumps, for example. And so as you can see between the 2 different animations, tracking panels increase the supply quite a bit in summer, slightly more in winter. And so perhaps it's a technology that must be left for large-scale projects. But that's also something that you can see easily on the different data sets available in the EnerMaps data management tools, visualization tools in particular. So you'll be able to read all these data stories on our website. And so before we go back to the plenary, I would like to give more time for a bit more time for discussion. I see that there's one question from Stefan, and 2 questions from Stefan, and perhaps I can quickly answer them now. They're in the main chat, and so they were answered already. But otherwise, if there are no questions, then perhaps Ina, if you want to share a bit more about the challenges of the energy transition in Plovdiv, now would be a good time.
Well, first of all, whoever has the time and the resources to come to Plovdiv, you're more than welcome. Beautiful city, great history, and great contemporary mood, so to say. We are kind of an artistic city here. We have hills and a great river. One thing that is not great about Plovdiv is our sustainable energy planning. Usually our local regional authorities are a bit lost in the ways that they have to do things so that the city moves forward towards more sustainability, being more green, more clean in terms of for example, air pollution, and not only energy, I mean, but definitely the things that we are facing here are related to the building renovation of our building stock is very diverse. We have historic buildings, we have multi-family buildings with so many apartments and so many residents inside. We don't have space for deploying renewables on site. We may utilize the rooftops. That's a very good idea. However, we need very concise estimations for that. We have energy poor households, and we have to address that as well. We have to change their use of fossil fuels, of wood abroad and change it to something more sustainable. We need a very good plan for that. We have issues with the air pollution that comes from the use of fossil fuels and low energy efficiency. We have to address that, and we're in a constant discussion with city authorities of how we can do that. Unfortunately, we always need some evidence, some numbers to provide them with, to say why, for example, changing 1,000 old wood stoves would be good for the energy efficiency in the city and for the quality of our air here. They need estimations, they need numbers and rationale for each and every policy that is being passed through for the city council or that is being embedded into the strategic documents. And coming to platforms, tools, and services like the EnerMaps, we come to a solution. We come to something that we can show our local authorities. We can tell them, see it for yourselves, how the situation may change in 5, 10, 15, 30 years ahead. And if you do this now, in the future, it will pay back so well, and it's going to achieve not only the energy targets, the environmental targets, the climate targets of the city, but it's also going to have some very positive impact on the social aspects, increasing the thermal comfort, for example, in the households, increasing the energy awareness, improving the energy behavior of the citizens. It's going to make the city more livable and more lovable, so say. So we highly appreciate each and every tool that comes our way that does that for us. I really like the storytelling in EnerMaps. It's a way to present the narrative of energy transition, how things happened or were back in the past, and how they can work out in the future. This is a way for us to show the future and to really dwell over the options that we have now and what we can invest in right now, so that we expect some positive benefits and some positive impacts in the future.
Mm-hmm. Thank you very much. Unfortunately, I might cut short a bit, but we're expected to join the plenary again for the end of the event. I think this was so it was recorded, and if that's okay, we'll share this because all the points are very useful, I think, in disseminating EnerMaps. So please join the plenary again on the left side in the menu at the top. You can simply leave here and join the plenary. And see you very shortly.
See you there.
Thank you.
Like to start now with our final official plenary that will allow us to conclude the project in terms of the official event and give you some hints on other ongoing initiatives. So with that, I'll go to the next slide. I'd just like to remind you that we have been talking about HotMaps a little bit. HotMaps was a previous H2020 project that led us to EnerMaps. It is a huge source of inspiration, and you can still find HotMaps online today. We were within EnerMaps, if we keep this analog analogy of the library. When we look behind the shelves, what is keeping our library together on the software architecture side, of course, able to improve some of the things that we addressed in HotMaps at first and EnerMaps a second time, so that in generally we reduce some of the overall functionalities. HotMaps, for example, has a user management, which explicitly we did not integrate into EnerMaps to avoid GDPR related questions. Here we're talking about open data, so that would not make too much sense to lose too much time on this. And on the other side, we were able to have a code that was a lot shorter in overall time, and it has an overall lines and has a lot less external dependencies, which leaves us to a code that's easier to deploy, because we also could use Docker, which at the time of HotMaps was still in the starting blocks. However, we also were able to reproduce and reuse some of the parts that HotMaps also put in place at first. Was the analysis tools, those calculation modules that we showed you in the different sessions now. Some even behind the scenes. So what is the code behind that? How is that working? And as well, as Giulia pointed out before the coffee break, is that there's wiki and the training material. Sorry for this. That is available, and that's built up on real case studies and story maps that are developed, so that that you see that there's a real use of it. When we go to the next slide, I'll just like to give a general conclusion. Thanks to COVID, we now ending up at 2 years of a completely remote H2020 project. This was not at all planned like this, so we had to adapt and, for example, work on our digital outreach compared to what we were supposed to do or thought we were doing, going to conferences and exchange there with people on it. We kept really everything on open access and open source, which I think is a key point in order to discuss and build trust on a platform. Within EnerMaps, we were able to explore larger data sets. However, as pointed out several times already during the discussion today, we hit some legal hurdles, especially on redistributing data that we saw coming, but we were surprised how persistent some of them were. So as I said earlier already, we had to reduce the number of data sets that we could distribute. On the other side, I think we now provide you a platform that is ready for you. It can be tested, as you could already during the different sessions, and you can go into more detail during the training. It can be reused as and even repurposed, as Historeno, first project, is already doing, and we're really curious to see what are you from the community thinking about it, and what might be your first reuse of it. So feel free to fork and tell us how that can be applied and how it's working for you. With that in mind, I'll go over to the next part, which will on the next slide, which will allow me to ask David Wannier to come up on stage. He's a professor at the HSSO and heading the ERANET Smart Energy Systems Open GIS for IT project, which just got validated and will start already next month for the next 3 years. And with that being said, I'll hand you over to David. You still have to unmute the microphone so that you can explain us a little bit about what is the project and how it links to existing efforts, HotMaps, EnerMaps, and now OpenGIS for IT as a third one in a row. So David, the floor is yours. Welcome.
Okay, thank you very much. Can you hear me well? Okay, perfect. Hello, everybody. My name is David Wannier. I'm professor at University of Applied Science, Western Switzerland. We have the opportunity to follow the job done in H2020 HotMaps or EnerMaps projects with this ERANET Smart Energy System OpenGIS for Energy Transition. In this initiative, unfortunately, not all EU countries attributed budgets, and we needed to reduce the number of partners to these 5 countries, so Austria, Denmark, Romania, Germany, and Switzerland. Next slide, please. Thank you. So you can discover here our partners, probably well known, because already involved in these former projects. So we have technical partners who will develop analysis tools or calculation modules, FlexShape, PPFL, Technische Universität Wien. We have implementation partner who will define, test, and validate the developments, Planenergie, eThink, that you know also. They are linked with cities in blue like Sonderburg, Frankfurt, Bistrita, and Lausanne is not written here, but will be also a pilot area, and some communication partners responsible for the dissemination like Modul 3, Energieagentur. Crem and the GSSO will be responsible of data on platform development. So next slide, please. We see here the objectives. So it's a EU-wide tool for energy planning with EnerMaps datasets integrated. So all the known job will be integrated here to follow the next 3 years of development. We will also add security because we will need to integrate private data, perhaps from building or for DSOs. So this will need to set up some DevSecOps approach. I will just explain shortly later. And creating a community, we will try to link the tool with other tools like Thermos or other needed tools or used tools by planners. So next slide, please. We see here in the middle the work package 1, open data collection lead by Jakob. On top of this, we have 3 additional calculation modules. One, the VP3 about mobility and resource efficiency, the VP4 with district heating and cooling at different temperature levels, and VP5 covering sector coupling and building flexibility, so like a bottom-up approach. In the bottom, VP6 will be the link with our pilot areas, and VP7 assume the knowledge transfer, communication, and dissemination. On the top of them, the VP2 will be in charge of the development. The next slide, please. As we have seen in Giuseppe presentation, EnerMaps is based on agile practices, Git repository, unit test, code review, and Docker containers. As we need to manage personal data in addition to public data, we need to set up security in the DevOps process. This is called DevSecOps. The idea is to check code at different levels: static, dynamic security testing, container vulnerabilities, and so on. That's the goal of this DevSecOps approach. And of course, GDPR compliance is also integrated in this best practice DevSecOps. So the next slide, please. Thank you. So thank you for your attention. Just short words about me. So I'm professor since 2012, teaching systems integration and software industrialization. In research domain, I'm responsible of the Energy Application and Systems Integration Lab and leading InnoSwiss projects, pilot and demonstration project of Swiss Federal Office of Energy. And before this position, I accumulated 18 years in several industries. So it's a great pleasure to coordinate this new ERANET project for the next 3 years.
So thank you, David, for that. As you could hear, I think the major concern from our side as lesson learned is to integrate more data in platforms, however, to have security by design and not like, and now we should integrate some measures to avoid data leakages. We have on one side, we keep the open data that is already available. And of course, in energy transition, different actors with their market position would like to use their data, but will not be able to share it, or even if sometimes they want, as you as a customer might be the owner of that data, but still there are ways and means of exploring them so that we can try to accelerate the energy transition together. That's kind of the key message, I think, of this project, in order to make a next step back a little bit to energy applications themselves, and not only the data gathering, which I think has now a wide basis thanks to EnerMaps, and can now go on to other cases like the one that you mentioned between between bringing mobility, district heating, and the electricity grid a little bit closer together, and see how those analysis tools, those calculation models, could help and create real test cases and help us advance. I'll just quickly look in the chat if there are any questions. I don't see any, which will, if there are none, lead us to a little sad moment in terms of EnerMaps, because I'll have to say thank you, David, but also go to the next slide, because I'll have to thank and congratulate as a coordinator the team of EnerMaps for the work that has been done. As I said earlier, it was 2 years of intensive work, but only online meetings more or less were possible thanks to different restrictions. I put up the logos of every institution that was involved, every partner. I did not put the screenshots of the different team meetings that we have. I think we can be pretty proud of what we have been achieved here, and we're happy to leave that behind for the next projects, as it's open for integration. Yeah, and again, from my side, that's I'm very happy. Was proud to lead EnerMaps. We'll work on the reporting within the next couple of months. And we'll keep in contact, and I hope that the people that were now able to listen and learn a little bit about the project can also take parts of it home and try to use it in their use cases. As I said, we are curious on learning on this. And with that, I'll pass over to the next slide of thanking you all for your attention. Feel free to reach out to us